Hello again, and as promised in this video I'm going to look at how do we balance a chemical reaction. And balancing has got to do with the fact that sometimes, for example, if I had a reaction like lithium, okay, which is a metal and therefore it is not a diatomic molecule sharing its electrons with others in a covalent bond, but rather in a metallic bond, plus oxygen, that which is a diatomic molecule, produces lithium oxide. Okay, lithium 2 oxide. Okay, so notice that in the beginning, in my reactants, I only have 1 lithium, okay, and 2 oxygens, while in my products, I have 2 lithiums and only 1 oxygen. So I need to somehow make sure that the number of atoms on the left-hand side is equal to the number of atoms on the right-hand side. Okay. First of all, I think what would be the easiest way is just to notice that in order to get the products to be 2, okay, to have 2 oxygens, I just need to make sure that I have 2 of these molecules. Okay, now just so that you know, you can never alter the little subscripts. That is what it is. Okay, you can't change the subscripts, but you can change the coefficient to any molecule, just telling how many of those molecules we will have. Okay, so if I have 2 of these, notice now, and I don't want to draw it because I want to actually avoid the visual demonstration, but now I've got 4 lithiums. I've got 2 of these molecules. In each of these molecules there are 2 lithiums, which means I've got 2 times 2, I've got 4 lithiums. But on the right hand side I only have 1 lithium. Okay, that problem is very easily solved. Just multiply that lithium with 4, and now let's see if it works out. Okay, I've got 4 lithiums on the left hand side. Okay, I've got 2 molecules with 2 lithiums in, so that means 4 lithiums. I've got 2 oxygen atoms, okay, on the left hand side, and I've got 2 molecules with oxygen on the right hand side, which means my equation is balanced. Okay, excellent. Let's look at another example. Okay, so here we have, this is iron 3 oxide. Let me write the name. Okay, iron 3, not like that, iron 3 oxide. Okay, that's the name of this product. Now you might ask, well, where does this 3 come from? And the 3 comes from the charge that iron must have. Okay, so when it comes to the transition metals, we can't just look in what group they are, because they're in their transition phase. Let me go to the periodic table. Okay, in this transition phase, they don't necessarily have 1 or 2 or 3 valence electrons, and they can have different number of valence electrons and therefore different charges. Okay, iron, for example, can have a positive charge of 1 or positive charge of 2. Okay, so let me go back here. So what does iron 3 oxide mean? Okay, well, or where does that 3 come from, and how could I have gotten it from this name? Well, we know that oxygen has a 2 negative charge because oxygen needs 2 electrons in order to fill out his highest energy level. Okay, oxygen needs 2 electrons. So if I have 3 oxygens, according to this, I have 3 oxygens, which means I am going to need a total of 6 electrons. Okay, I'm going to have a total of 6 electrons. I'm sorry, I don't have space here. Hopefully you can see this 3 tells me I've got 3 oxygens. Each one of these oxygens needed 2 electrons to fill out their highest energy levels, which means I needed a total of 6 electrons, okay? And these electrons were supplied by iron, okay? Iron, in this case, is the cation, okay? The supplier of the electrons, and in order for 2 of these ions to give 6 electrons, it means that the ion must have had a positive charge, or must now have a positive charge of 3. Hope that makes sense, and that is why we say this is iron 3, iron with a positive charge of 3 that has bonded with oxygen. Okay, so now I've messed up my, let me take that off so that we can just do the balancing, but I thought that naming was important for you to know, but let me go on with balancing this equation. We can definitely see that this is not balanced because immediately on the right hand side I only have 1 ion while I've got 2 ions on the left hand side. So I can try and just fix that by putting a 2 there. Okay, is it fixed now? But now I see I have a problem here because I've got 3 oxygens on the left hand side and 3 oxygens on the right, and 1 oxygen, sorry, on the right hand side. So I can put a 3 in front of there. Okay, and now finally I can I see that hasn't changed the ion at all, and now I can see, okay, now on the right hand side I've got 6 hydrogens, 3 times 2, and I only have 2 on this side, so if I multiply with the 3 here, I've also got 6 on this side. And there we go. Let's quickly make sure 2 ions, so let's count them like this. I've got 2 ions on the left, okay, I've got 2 ions on the right. Let's check oxygen. Oxygen, I've got 3 on the left, and I've got 3 on the right. Okay, 3 on the right, and then the next one is hydrogen. Hydrogen, I've got 6 on the left, and on the right I've also got 6. Okay, that means my equation is balanced. Now, a balanced equation is incredibly important, and the reason why it is important will become much clearer when we get to later topics, especially when we get to chemical changes, but also in knowing how much, if I am using a certain amount of iron 3 oxide and a certain amount of hydrogen, how much hydrogen do I need in order to react with all of this, okay? Because according to this, I need 3 times as much hydrogen as I need iron 3 oxide, okay? And as a result, the products will give me 2 times as much iron as I started, iron oxide I started with, and 3 times as much water as the iron oxide I started with. Okay, but more about that a little bit later on how these coefficients have an incredibly important role to play in the actual chemical processes. Okay, let me try quite a difficult one this time. Okay, so in this equation, I'm not going to confuse you with the names of all of these compounds at this stage. Okay, rather we'll just go into a basic mathematical process of trying to get the left-hand side's symbols to be the same as the right-hand side's symbols. Okay, so to do these, I'm going to give you 3 pieces of advice, and they may sometimes not work. I don't know if they will work always, but they are helpful. Okay, first start with the element represented once in the products. Okay, so in this case, the only element that's represented well, there's a few. Okay, elements represented once in the product. There is sulfur, iodine, and oxygen. It's actually only hydrogen that's is more than once. Okay. The second one is do oxygen second last. And the final one is do hydrogen last. Okay. And that's usually because hydrogen will be all over the place. Now, it doesn't mean if you just follow these steps 1, 2, 3, you'll have it sorted. You still have to edit here and there. So let me illustrate it. Start with the element represented once in the product. Okay, so I'm going to start with S. On the left hand side and on the right hand side, I've got the same number. I've got one S on the left, one S on the right. I'm happy. So I'll move on to the next element represented only once, iodine. Okay, iodine is twice represented in the products and only once in the reactants. So I'm going to need to add 2 more of them in the reactants. Okay, and now the next one would be yes. Okay, do oxygen second last. I only have oxygen and hydrogen left. Okay, oxygen on the left hand side is represented 4 times, and on the right hand side is only represented once. So I'll need to multiply the right hand side oxygen with 4. Okay, that only has another effect on the hydrogen. Okay, so now notice that if I have to do the hydrogens last, I've got on the right hand side 2 plus 4 times 2 is 8, so I've got a total of 10 hydrogens on this side, and on the right hand side I've got 1, 2 plus 2, which means I've got a total of 4 on the left hand side. Okay, so I've got way more hydrogens on the right hand side than on the left hand side. Now, if I change this one, it will have an effect on the right hand side on here. Okay, if I change this one, it will also have an effect on the right hand side, because if I multiply this one, I'll have more S's. Okay, and you can see on this side, whatever I multiply on this side, I'll have to repeat on this side again. So my point being is that this one's coefficient here must be the same as that one's coefficient, because both of them have only one S in, and this one's coefficient must be double that one's coefficient. Okay, so since it's very easy to change these coefficients because they have limited effect, but the problem is the moment I change this coefficient here, I all of a sudden have more oxygens, and then I'm going to have to change this one to get the more oxygens, which means I'm going to end up having more hydrogens again, which just means I'm going to have to start editing the hydrogens at some other point. Okay, so it is a matter in this case, at this stage, of trial and error. So what I'm going to do with this one is I'm just going to try and get close by, remember we need 10, and I can get 10 by multiplying this one with 4. Okay, not 4, 8. Multiply that one with 8. Okay, if I multiply this one with 8, I can change this one. I must change this one to 4. Okay, because this one must always be half of that one. Okay, let's see if it works out now. Okay, I've got, let's start with hydrogens. Hydrogens on the left, I've got 2 plus 8 is 10 on the left. On the right, I've got 2 here and 8 here, so I've got 10 here. So my hydrogens are sorted. Okay, let's try sulfur. Okay, sulfur, I've got 1 in this molecule and only one of the molecules, which means I've got 1 on the left hand side. On the right hand side, I've got 1 on the right hand side. Okay, which is great. Okay, then oxygen. So the next molecule, I've got 4 here, 4 in this molecule. I've got 1 molecule, which means I only have 4. On the right hand side, I've got 1 in the water molecule, but I've got 4 water molecules, which means I've got 4. And then for the next one is iodine. Okay, iodine, I've got 8 on the left hand side, and on the right hand side I've got 4 diatomic molecules, which means I also have 8 atoms on the right hand side. And there we go, I've got this one balanced, and as a matter of fact it is actually quite a difficult one to balance, and yet following these steps and just looking at the relationship, which one is only represented once on the left and once on the right, we know that their coefficients must be the same. Okay, the which ones are only represented once here and once there, but the one has a subscript, okay, which means that defines the relationship between its coefficients. Okay, so all of these things come into play, so that in the end it is a matter of trial and error and finding the correct combination. Just so you know, I did not do this before the time. I tried doing it on the spot, and I just followed these steps. So I'm trying to find the most difficult one that I could just do on the spot. Well, I hope this video was helpful in helping you to understand how to approach balancing chemical equations. It is a tremendously important topic, so please make sure that you are very comfortable with doing it. It's seldom this difficult, but that does come up. Most of them are quite simple and straightforward, but make sure you understand how to do it and why you are doing it. Thank you very much for watching. I'll see you in the next video.